This is Dr. Hold. I want to go over a physics problem where we have inclined planes. It's an inclined plane problem, but we're going to have friction on this example. I'll show you a picture of this one. We're going to look at a mass here. We have a mass of 60 kilograms. It's on an inclined plane of 40 degrees. We have mu of s and mu of k. Mu of s, that's our static coefficient of friction, and mu of k is our kinetic coefficient of friction. Alright, again, as I said on one of my earlier videos, I recommend that you set these up into another axis system called x prime and y prime, and then work strictly within this axis system itself and not work within the x and y axis system. It's going to be a lot easier for you. Alright, so let's go back and we'll work this problem. So again, first thing you're going to do with a problem like this is take the 60 kilograms, let's turn it into a vector, because we know the acceleration of gravity at the surface of the Earth is about 9.8 meters per second squared. So we're going to create that into a vector, and we will go ahead and multiply that. So if I take 60 times 9.8, that's going to give me of about 588 newtons. So I got 588 newtons coming down. What we're going to do now is always break this into, let me slide this over a little bit. Always break this into the components. So we're going to create this as our axis system. We said this is y prime and this is x prime. So I'm going to come down here. I'm going to draw this vector coming straight down here. I'm going to draw this vector here coming straight down here. Okay, and I'll go and just show this angle as being 40. Again, if this is 40 here, this angle here has to be 40. Prove that with geometry if you need to, but it's always going to be the case. Whatever this angle is, this angle here will always be the same. This will be a right angle. We're going to label this as the force of the object in the y prime direction, and we're going to label this as the force of the object in the x prime direction. Okay, we're going to run those numbers, and then F of the object, force of the object in the y prime direction, is going to equal to 588 times the cosine of 40 degrees. When we do that, that's going to give us a value of about 450.4 newtons, and that's going to be coming straight down this direction here. That's going to be parallel to our y prime axis. The force of the object in the x prime direction is going to equal to 588 times the sine of 40 degrees. That's going to give us a value of 378 newtons. That's going to be coming straight down. Okay? Alright. So now let's go ahead and run our, let's go ahead and sum our forces. Well, actually, let's go ahead and draw a free body diagram. So a free body diagram is, when we draw a free body diagram, we're going to ignore the 588, and we're only going to use as two components. We're going to use the 450.4 and the 378 newtons. So let's pick a point here. Pick a point here, and what's going to happen is we're going to have 450.4 going this direction. We're going to have 378 going this direction. We're going to have friction that's going to try to resist that motion going back this way. We'll call that our force of friction. And then we're going to have a normal force called Fn. Okay, so that's our free body diagram of what's taking place of the mass on the inclined plane. Alright, so what we're going to do now is we want to sum the forces in the y prime direction, and we want to sum the forces in the x prime direction. Okay, if we sum the forces in the y prime direction, then I'm going to get minus 450.4 plus our Fn normal must equal to 0, because the object has to be in equilibrium perpendicular to the inclined plane, because the object's not going to start accelerating away or through the inclined plane. We do that, we can find immediately that our normal force is going to be 450.4 newtons, and that's going to be going back up against the inclined plane. All right, we sum the forces in the x direction, then we're going to get minus 378 plus our frictional force. Okay, by definition, frictional force is always going to be equal to the normal force times mu. So we know what the normal force is, so let's go ahead and figure out what that's going to be. So F friction is going to be equal to our normal force, which we said was 450.4. Okay, slide this up a little bit more. You want to go ahead and multiply it by the coefficient of static friction first to make sure the object is even going to move. So if we multiply that by 0.3, then I will find out that the static friction is 135.12 newtons, and that's going to be going back up, a resisting motion. Okay, so that's our static coefficient of friction. Now, since this object here, since this force here, the minus 378, is greater than the 135, because I can put the 135 back into this equation, I can find out that my net force is going to be negative, because it means I'm going to start moving down the inclined plane. So, since this value here, the absolute value of this is greater than the absolute value, greater than this value here, the object has to move. It has to move in the negative direction. Okay, now let's go ahead and figure out what our frictional force is going to be in the kinetic. Kinetic means the object is actually moving. We're going to take 450.4, we're going to multiply that by 0.2. So when we do that, that's going to give us a value of 90.08 newtons. And again, that's going to be pointing back up this way. Alright, so now, since we know the object's going to move because the force is greater than the static frictional force, we go ahead and use only this force in determining our accelerations. So again, we would go back to this equation here. We'll put the value in. So if we sum up our forces in the x prime direction, I will have minus 378 plus 90.08 newtons. We run that value and we'll get a minus 287.92 newtons. So that's our net force. That is our overall net force of this mass. Now to go ahead and find our acceleration, we just do, we're just going to do F equals ma. F is equal to mass times acceleration. We put minus 287.92. We set that equal to our mass, which we said was 60 kilograms. We'll multiply that by A. And when we do that, we will find that A is equal to minus 4.8 meters per second squared. So that means this object is going to accelerate down the inclined plane at a rate of 4.8 meters per second squared going down the inclined plane. So again, these problems are not that hard. Just follow a methodical approach. Again, always check to make sure that this force here, your force of the object in the x prime direction, is always greater than the frictional force, the static frictional force. If that's the case, then you go directly to the kinetic frictional force and find out what that is. Because once the object is in motion, the kinetic frictional force takes effect. Alright, so again, we could find out what the acceleration is just by summing the forces, find out what our net force is, and then dividing by the mass of the object and get our acceleration. Alright, best of luck with these problems.